Hey guys, I'm here to teach you about stoichiometry. So maybe you will find it a little bit easier and hopefully you will be able to master it by the end of this video. So today I'm going to talk about moles and percent composition. So let's get started. Our first question is, what is the volume of 2.4 moles of water vapor at STP? I know what you're thinking. What is STP? Well, STP means standard temperature pressure, but don't worry because you don't need to know that in order to solve this problem. So the first thing that we're going to need to look at is the word volume. When it's talking about volume, it really means liters. So how many liters are in 1 mole? Well, I already have that conversion, and 1 mole is equal to 22.4 liters. So now that we know that, we need to go to our steps. So our first step is we need to state the given. The second step is we need to convert to what you need. Third is we need to set up the equation, and 4, we need to solve. So starting with number 1, state the given. In our question, it says that we have 2.4 moles of water vapor. So let's just go ahead and write that down. 2.4 moles of water vapor. Just like that. And using our conversion of 1 mole is equal to 22.4 liters, we can then find step 2, convert to what you need. We need liters. So first we need to cancel this mole out. In order to do that, we would need to put 1 mole at the bottom, and 1 mole, using this, is equal to 22.4 liters. So we just did step 3. We just set up the equation. So now it's time for step 4, which is solve. So usually if you have a problem like this, which is dimensional analysis, you would multiply everything on top and then multiply everything on bottom and divide those two numbers. But since there's just a 1 at the bottom, all we have to do is multiply these top two numbers, and that would give us our answer. So 2.4 times 22.4 should give us 53.76. But we're not done yet because we need to put our units. Units are very important. And so we would put liters per mole. And then that would be your final answer. 53.76 liters per mole. All right, so let's move on to percent composition. So let's look at our problem. Find the percent composition of all the elements in phosphorus triiodine. What is triiodine? So let's break it down. Let's look at the first part, tri. Tri means 3. So it's really just saying that there's 3 iodine elements in this formula. So the formula would be Pi3, 1 phosphorus and 3 iodine. So now that we know that, we can go ahead and look at our steps to solve. So number 1 is that we need to find the masses of each element. Number 2 is that we need to find the molar mass. Number 3 is we need to divide the mass divided by the molar mass, or part over whole. And 4 is that we need to multiply that number by 100. And 5 is that we need to check our answer. So let's start with number 1, finding the masses of each element. So let's go ahead and start with phosphorus. You can find the mass of phosphorus by looking on your periodic table, and it says that phosphorus has a mass of 30.974. And since there's just 1 phosphorus, we don't need to multiply it by anything. And now let's move on to iodine. Iodine has a mass of 126.904. But since there is 3 of them in this equation, we have to multiply that mass by 3. So let's go ahead and do that. And when you do that, you should get 380.712. So iodine's mass is going to be 380.712. So step 2 was to find the molar mass. And molar mass is really just all the mass of masses of each element added together to make it one mass. So in order to find the molar mass of this equation, we would do 30 plus 30.974 plus 380.712. And if we plug that into our calculators, we should get 411.686. So this number right here is going to be our molar mass. All right. So now that we did step 2, we can move on to step 3. We need to divide mass over molar mass, or part over whole. So let's start with phosphorus. We can put our mass on top, 30.974 on top, and we can divide that by the molar mass that we just found, which was 411.686. And when you plug this in your calculator, you should get a decimal. So when we plug that into our calculator, we get 0.075. And what we're looking for is a percent. So step 4 is saying that when we find this, we need to multiply it by 100. So let's go ahead and do that. And that would give us 7.5%. So that would be our answer for phosphorus. Now let's go ahead and do iodine. So iodine's mass was 380.712. And we need to divide that by the molar mass, which is 411.686. So when we plug that into our calculator, we would get 0.925. And then step 4 is multiplying by 100. So let's go ahead and do that. You'd get 92.5%. Okay, so number 5 is check our answers. And there's a really cool way to check your answers when you're doing percent composition. So when you're doing percent composition, all your percentages should add up to 100. So when you're checking, you could just go and do 7.5 plus 92.5. And if we plug that into our calculators, we would get exactly 100. So we know that we did this equation right because our percentages added up equals 100. So our final answer for this problem would be phosphorus 7.5%, iodine 92.5%. And that is all that I have for you guys today. I hope that this video made it easier to master stoichiometry and made it easier for you to do percent composition and moles and converting and all that. So, bye guys.